So, sorry I can't be with you today. Listen through the lesson. It's broken up into a few parts, and when you're done, then you have homework to complete on page 111. Okay, let's get started. We were introduced to the term limit in trying to find a tangent line to a curve or the velocity of an object. We now look at limits in general and the numerical and graphical methods for computing them. So given a function y equals f at x, we are interested in finding out what happens to y when x approaches, but doesn't necessarily reach a certain value. So for example, if we have this equation, f at x is 2x squared plus 1, what happens when x approaches 1? So let's try it. That is, let's let x equal 0.9 and put x equal 0.9 into our function. 0.9 squared times 2, add 1, and we get 2.62. Try it with 0.99, and we get 2.9602. Plug it in your calculator for 0.999, and I'm getting 2.996. And so we can see as our x values get closer to 1, which is what we were looking for, so x is getting closer to 1, the y value that was coming out was getting closer and closer to 3. So that was approaching 1 from the left-hand side. So approaching 1 from the left. And then what if we happen to approach it from the right? That is, choose numbers larger than 1, and then but just keep on getting a little bit closer to 1. So here we can see once again we are approaching the value of 1. Our x is approaching 1. So x approaches 1. What happens to y? Well, let's try it. 1.1 squared, multiply it by 2, add 1. 1.01, square it, multiply it by 2, add 1. 1.001 squared times 2, add 1. And we can see that these are getting closer and closer to 3. So what we say then is we say the limit of our function f at x, which equals 2x squared plus 1, as x approaches 1 is equal to 3. And like all good mathematicians here, rather than write an entire paragraph, I'm just going to put it down symbolically. So this is the notation we need to get comfortable with. We say this: the limit as x approaches 1 for our function 2x squared plus 1, that limit is equal to 3. Okay, which is a whole lot of work when you already knew the answer to the question, but we are going to be working with functions where you don't. So here's our definition of a limit.